In this video, we're going to look at average value of a function. Here's the motivation. Let's say we have 5 temperature readings on January 1st, 2020 in Vancouver, Canada, recorded at various times of the day as follows. 1 degree centigrade, 4 degrees centigrade, 7.5 degrees centigrade, 6.7 degrees centigrade, and 4.5 degrees centigrade. We can calculate the average daily temperature as just the average of these 5 numbers. So T average is equal to 1 plus 4 plus 7.5 plus 6.7 plus 4.5 divided by 5. That's equal to 4.74 degrees centigrade. Let f of t be the recorded temperature during a 24-hour cycle. Then T average would be 1 over 24 summation I goes from 1 to 24 f of ti. So basically what we're doing is we're taking the 24 readings, temperature readings, hourly temperature readings, and summing them and then dividing by 24 to get an average value of the temperature, to get an average temperature for the 24-hour cycle. Basically, the T average is going to be 1 over 24, summation I goes from 1 to 24, f of Ti. Now, let's imagine that instead of recording 24 hourly temperatures, let's make n temperature recordings during the day to improve our estimate of the average daily temperature. For example, every minute, every second, every millisecond, every millionth of a second. So you can see that that's the idea of getting a much better estimate of the average. So T average would be 1 over n, summation I goes from 1 to n, f of Ti, and this kind of looks like a Riemann sum. So we're going to make it look like a Riemann sum. Let's start with delta T, the change in time. That's equal to B minus A divided by n. Now solving for n, we get n is equal to B minus A divided by delta T. And now flip both sides, we get 1 over n is equal to delta T divided by B minus A. So T average is going to be 1 over n, which we have solved here as delta T divided by B minus A, summation I goes from 1 to n, f of Ti. This is equal to 1 over B minus A, summation I goes from 1 to n, f of Ti times delta T. So basically, let me just rewrite this so it looks nice. F of Ti times delta T. Delta T, we basically brought it inside the summation. So now what we have is, let's take the limit as n goes to infinity. So limit as n goes to infinity, limit of the Riemann sum is going to give us an integral, a definite integral. So T average is going to be equal to limit n goes to infinity, 1 over B minus A, summation I goes from 1 to n, f of Ti, delta T, and in the limit this approaches the definite integral 1 over B minus A, integral A to B, f of T, dt. Alright, so for a 24-hour cycle, T average is equal to 1 over 24, it's a definite integral, 1 over 24, 0 to 24, integrate from 0 to 24, f of t dt. So in general, T average is equal to 1 over B minus A, integral A to B, f of t dt. So we can now define the average value of function as f average is equal to 1 over B minus A, integral A to B, f of x dx. So in this case, T average, the average temperature, is 1 over 24 integral from 0 to 24 f of t dt. And this is essentially the green line that we have here, and this is t average right there. So this is essentially the average height of the temperature function. All right, we're going to illustrate this with a concrete example. So first, let's look at a theorem. The average value theorem, if f of x is continuous on the closed interval ab, then there exists x equals c in ab such that f of c is equal to f average is equal to 1 over b minus a integral a to b f of x dx. Or equivalently, let's multiply both sides by b minus a. We get f average times b minus a is equal to integral a to b f of x dx. So the geometric picture is that the area of the rectangle, f average times b minus a, is exactly equal to the area under the graph of f of x from a to b. So this is the key concept. The area of the rectangle, this rectangle here, the green shaded rectangle, is exactly equal to the area under the curve of f of x from a to b. All right, so let's write this down. F of c times b minus a is equal to integral a to b f of x dx. The left-hand side is the area of the rectangle, and the right-hand side is the area under the function f of x from a to b. All right, so now we have an example. Given f of x is equal to root x, on the closed interval 1 to 4, find the following. Find f average is equal to 1 over b minus a integral a to b f of x dx. So find the average value of a function. That's part A. Part B, find x equals c such that f average is equal to f of c. That means find the x value such that the average value f average is equal to functional value. Part C, sketch the function f of x is equal to root x and a rectangle whose area is exactly equal to the area under the graph of y equals root x. So let's start with part A. F average is equal to 1 over 4 minus 1 integral 1 to 4 root x dx. That's equal to 1 over 3 integral 1 to 4 x to the 1 half dx. This is 1 over 3. X to the 1 half plus 1 is 3 half. Divide by 3 half, that's 2/3. From 1 to 4. Now we apply the fundamental theorem of calculus to find f average. F average is equal to 2 over 9 x to the 3 half from 1 to 4. Now apply FTC, we get 2 over 9, putting the upper limit in, 2 over 9 times 4 to the 3 half minus 2 over 9 times 1 to the 3 half. Now 4 to the 3 half is essentially 4 to the 1 half cubed. That's going to be 8. So we get 2 over 9 times 8 minus 2 over 9. So that gives us f average is equal to, well, this is 16 over 9 minus 2 over 9. That gives us 14 over 9. So 14 over 9, this is f average, the average value of the function. And if we decimalize this, we get 1.56. All right, part B of the question is find x equals c such that f average is equal to f of c. So the solution is f average is equal to 14 over 9. F of c is equal to 14 over 9. Solve for c. So f of c is equal to root c. That's the function. Let's make this equal to the average value that we found earlier and solve for c. Remember, c is the x value. So now square both sides, we get root c squared. So root c all squared is equal to 14 over 9 all squared, and we will get c is equal to 2.42. This is the x value. X is equal to c is equal to 2.42. So now let's look at a geometric picture of this rectangle. The 2.42 that we found is actually right here. So you can see how the function at that point, and this is essentially f of c right here. F average is 14 over 9. So the idea is that the integral from 0 to 4 root x dx is equal to f average times 4 minus 0. That's 14 over 9, the average value of a function, multiplied by 4. This gives us the area under the curve, 6.222. But the key concept here is this, that the area of the rectangle is equal to the area under y equals root x. So the green shaded area is equal to the area under the curve. And the value that we found here, which was c, is equal to 2.42. And at that point, we evaluate the function, and that's the average value of a function. And so basically, if we get 14 over 9, multiplied by 4, this is the area of the rectangle. This gives us the area under the curve, 0 to 4, root x dx. All right, thank you.